Today's lesson is on writing and finding the equations of exponentials. At the end of this lesson, you should be able to compare functions represented in multiple ways, graphically, algebraically, in tables, and verbally. And you should be able to write the equation of an exponential function. You will need your calculator for today's lesson, so make sure you have it available. Exercise 1. An exponential function of the form f of x equals a times b to the x is presented in the table below. Determine the values of a and b and explain your reasoning. Now we're going to do this two different ways. We're going to do it the algebraically way, I guess, and then we're going to use our calculator. Both ways are acceptable for testing and quizzing. So the first one, they give us a table, they give us our x values, they give us our y values, and remember y is the same as f of x. So we need to find out what a is and what b is. Now remember, a is your y-intercept. It's where x equals 0. Now this is only true when it's in this form. If we have an equation that has a shift up or down, which we did in our last lesson, we know that this isn't true. The good news in this class is we're only going to deal with equations or writing them in the form that looks like this. Okay? So we know that our a value is 5. Now our b value is what we multiply by, your multiplier. So if I look at 5 and I go to 15, what did I multiply by? If I go to 15 to 45, what did I multiply by? 45 to 135, what did I multiply by? So 5 to 15 is probably the easiest. You multiplied by 3. So in your calculator check, 15 times 3, does it give you 45? 45 times 3, does it give you 135? And your answer is, yes, it does. So I know my b value is 3. Therefore, my final equation is f of x equals 5 parentheses 3 to the x. And my explanation is that a equals the y-intercept where x equals 0, and b equals what y is multiplied by. There you go. So now let's practice doing a regression on our calculator to make sure we're good to go. So grab your calculator. So on your calculator, you're going to go Home, New Document. We need a list and a spreadsheet. You have to label your columns. So in the box A, put x. You have to go down, over, and then up, put y. We're going to put our x values in, so 0, 1, 2, and 3. Then we're going to put our y values in, 5, 15, 45, and 135. Make sure you hit enter and you get out of that last box. Remember, you have a yellow sheet with your regression information on it. So Menu, Statistics, Stat Calculations, and this time we do not want a linear regression, we want an exponential regression, because this was an exponential function. So what was our x list called? X. What was our y list called? Y. And then click down to OK. So there it tells us our equation, it tells us what a is and what b is. Now, remember there's another way to do this. If you don't want to, so let me undo these. If you only want to do x and y in your calculator, another way to find the regression would be then to go home, do not hit New Document because that will wipe out your data. Go down to the one that looks like a bar graph. We need to add our variables. So this is our x-axis, so we're going to click and call it x. And we watch the dots dance. Then we go over to where the y-axis is. We click and we put in y. And we notice, wow, that really looks like an exponential graph. So this is called a scatter plot. So we need to get the graph or the equation off of this graph or this scatter plot. So y equals Now this one's a little different. Number 4, analyze. Now you can see in number 6, the regressions. We need to pick show exponential, and there it is. The reason that I like this better is that it puts it into the equation right away for you. So you'll notice it says 5 is our A value, 3 is our B value. So now we're going to look at exercise 2. Finding an exponential equation becomes much more challenging if we do not have output values for inputs that are increasing by unit values, increasing by 1 at a time. Let's start with a basic problem. For an exponential function of the form f of x equals a times b to the x, it is known that f of 0 equals 8 and f of 3 equals 1,000. Use the fact that f of 0 equals 8 to determine the value of a. Now we already know if f of 0 equals 8, x equals 0 and y equals 8. So we know we have the ordered pair 0, 8. That is the y-intercept. And we know the value of a is the y value of the y-intercept. So we know a equals 8. So now in part B it says use your answer from part A and the fact that f of 3 equals 1,000 to set up an equation to solve for B. You will solve for B in part C. So we're going to use our equation f of x. So we're finding f of 3. We know that a is 8. We're looking for b. And we know that our variable is x. Now we know f of 3 is 1,000. So we're looking for b. So, sorry, this should be a 3, because that's x. Can't have two variables. All right, so the first thing we're going to do is undo what? Multiply by 8 or an exponent of 3. So to undo, we're going to divide by 8 first. And this should be down here. Sorry, I did it again. So 1,000 divided by 8 is 125, and that equals b to the third. Now, if you're unfamiliar how to undo your exponents, or you don't remember, if we have an exponent of 2 squared, to undo it we use a square root. We have a button on our calculator that allows us to raise an x to any exponent, and that's our caret button right here. We use that a lot. So to undo an exponent of any power, we're going to use this blue button above it. So I need to get a calculator page. So I'm putting in 125. So I need to hit this button. You're not going to be able to see it till I open the screen. There it is. And I'm putting the exponent in here, which is called the index, and I'm putting the base here, 125. So just like a square root undoes a squared, a cube root, that's what that 3 means, cube root undoes a cube of 125, and hit enter. So 5 times 5 times 5 must equal 125, and it does. So 3 5s being multiplied gives me what's underneath my radical 125. So b equals 5. So how do we determine the value of f of 2? Well, we know our equation now. F of x equals 8 times 5 to the x. So f of 2 equals 8 times 5 squared. So grab your calculator again and do 8 times 5 squared. And that is 200. So f of 2 equals 200. Now if you're thinking, wow, that was kind of hard to know cube root and stuff like that, you could have done the regression. So home, new document, no save, our regression, put in x, put in y. We had 0 and then 8. And then they told f of 3 equals 1,000. So we could get our scatter plot, click x, click y, It really doesn't show if it's linear or exponential, but we know they told us to write an exponential. So menu, analyze, regression, exponential, and there's our equation. So we didn't have to necessarily solve this algebraically. We could have used our regression, okay? And that's what we're going to do on exercise 3. So exercise 3 says, find the equation of the exponential function of the form y equals a times b to the x that passes through the points 236 and 5, 121.5. Well, those just look like giant numbers and there's a decimal. So we're going to use our calculator. So again, home, new, no, list and spreadsheet. We're going to do x, over and up, y, plug in your x values of 2 and 5, go over and plug in your y values, 36 and 121.5, home, click on x, click on y. Really doesn't tell us anything by the scatter plot, but we know it's exponential. They told us so. So analyze, regression, exponential is number 8, and there she is. Y equals 16 parenthesis 1.5 to the x. So our base is a fraction or a decimal, so that would be very challenging for us to do algebraically. What kind of work are you going to show? Well, I would say make your table. And then say exponential regression. And that tells us how you found it. All right, pause the video and try example 4. One of the things I forgot to mention, at the top of the page I would highlight, I knew I could do a regression because any two non-vertically aligned points will uniquely determine the equation of an exponential function. Now it makes sense because if they're vertically aligned, that's not exponential. That's a straight line. So that's how I knew I could use a regression for this. And they told me exponential function. So on the next one, I'm going to do the same thing. I'm going to grab my calculator, home, new, no, list and spreadsheet, go up and put x in, go over and up and put y in. My x values are -2 and 2. My y values are 128 and 1/2. So now I'm going to go home, data and statistics, click on x, click on y. We notice it's going the opposite direction this time. It's decreasing. Wonder what that means. Menu, 4 for analyze, 6 for regression, 8 for exponential, and look, for decreasing, I look and I notice that my base is less than 1, but greater than 0. So my equation is y equals 8 times 0.25, or 1/4, to the x. What am I writing down for work? My table, which is -2 and 2, 128 and 1/2. I am writing down that I did an exponential regression. Very nice. All right, let's try a word problem. So why don't you pause the video and at least read it, highlight what's important. So the first thing you'll notice is what I highlighted, and the second thing you'll notice is I put an A and a B, because we do not tend to separate the parts of the question, which you might be used to. So I put A and B to remind myself that there are two parts to this question. So first, let's make a table. You know we're going to use a regression because we're asked to write the equation in y equals a times b to the x form. So my x is my hours, and I'm going to write that there, and my y is my bacteria. So x hours, 4 hours, 98 bacteria. 9 hours, 189 bacteria. So go ahead, let's grab our calculators. Home new. Oop, new. No save. List and spreadsheet. Up input X. Up input Y. X values are 4 and 9. Y values are 98 and 189. Home, data and statistics, the bar graph one. Click on X. Click on Y. Then do menu, analyze, regression. We want an exponential number 8. And we notice, wow, we've got a lot of decimals. But we notice in the question they asked us to round to the nearest hundredth. So 100 has 2 zeros, so I'm rounding to the 2 decimal places. So y equals 57.95 times 1.14 raised to the x. Now again, remember, this is your y-intercept, or your start value, sometimes called your initial value. This is your, what you're multiplying by, your growth, because it's greater than 1. So the second part asks, at what % rate is the population growth per hour? So we need to know if it's greater than 1, it's growing. Well, that's because if we multiply by 1, it doesn't change. So how much more than 1 is 1.14? So 1.14 minus 1 is 0.14. Now, 0.14 as a percentage rate, so I probably should have highlighted that. Percentage rate. I need to move the decimal over too. So it's a 14% growth per hour. Good luck with this. If you have any questions, don't hesitate in class.